I'm creating an Arduino powered RC transmitter, and in this video, I show you what it takes to finish it, which includes, but is not limited to, moving into a new house, getting a new desk, creating the case, coding the UI, and then making it actually control something. And finally, I unboxed something from PCBWay you will not want to miss. Part of the reason I haven't posted for the first 3/4 of this year was because we moved into a new house. I have a much bigger office space now, as you can see, and I am so happy with my setup. But the table I chose for my desk was underwhelming. And then Daniel from FlexiSpot reached out to me about their standing desk, and I knew what I had to do.
This thing is so nice. So it's gonna replace this desk, and I installed the control panel on the right. So I'm gonna have to switch it to the other side. Now I need to take my desk, put it over here, and then put all my crap on the new desk. Let's do it. I finally have everything set up. My old desk is over here blocking that door, which is great. Here's what we look like from the back. So here we go, and I can now work while standing.
30 days into the future Acer here, and I can confirm this desk is the real deal. I mean, I can literally lift my wife and Pika, and combined they weigh the same as like 11 Pikas. Anyway, if you're interested, check out the link in the description. And if you end up buying one with the link, I get a 10% commission, which helps a ton with affording these robotics projects. Now, that may affect your perception of what I'm about to say, but seriously, if you're looking into a new desk, I highly recommend at least checking out FlexiSpot's desks. Now that the desk is set up, it's time to use it. These simple handles are finished. The big issue I had was trying to blend this face with this face. I ended up using loft. If you just loft it without a rail, it looks like that. But having this curve here and then having it follow that curve makes it, you know, do exactly what I wanted. I will have to print the entire controller over again, but that is just the cost of doing business.
This goes on. Nice. Look at that. Just how oh my gosh, that feels so good. Guys, I cannot stress how much of a difference this curve makes compared to this. Something's wrong. I don't want to like hurt it. Oh, okay. This plug is getting in the way of this. Is there anything else that's wrong? This hole isn't big enough. Okay, let's make the fixes and reprint it.
The two changes are made, and I actually made a third additional change that I wanted to show you guys. Now the top case covers the giant bottom bezel of the screen, so only the actual screen is showing.
That's it for the bottom. Plus on the right. Here's the new top. Hopefully second time's the charm. Let's test it out. Come on. I don't even know what could be wrong with... Oh, wait. Hopefully that was the issue. Oh, yes, we're good. Let's go. There's an issue. This part right here is getting in the way of the triggers. Look at that. Perfect. Bam. Oh, this is so nice. All right. Last but not least, actually, hold on. Last but not least, the handles. All right, here it is. I haven't tested if it turns on yet. Hopefully it turns on. It'll be a little awkward if it doesn't. Uh-oh. I installed the battery thing backwards.
You'll notice that these screws are here. I actually didn't screw in the back screws because I don't need to. One benefit of the handles being like attachments is that you can customize your own. You can make these look like whatever you want. Now I get to make the user interface. I've gotten to a pretty good point with the toggles. So there's the code. Here's what my mock-up looked like. And here's what it looks like in real life. I mean, as you can see, when you hit the switch, it is reflected on the UI. It's a little visually cluttered. Like, I like the idea, right? You might be thinking, well, to see the status, why don't you just look at the switch? I don't want you like looking back and forth. You shouldn't have to like link up the word with the switch. I think this is the cleanest way to go, even though it's a little less clear if it's on or off, like right now. There's less things visually happening. I think we're gonna go with underline. I'm just finishing up the info display on the right. Okay, that's 14, that looks pretty good. That needs to be 14. Yeah, so info display, we've got battery level of the Hexapod, we've got the amount of amps the Hexapod is pulling, power of the Hexapod, and then finally we've got the height on the bottom. No idea how long the Hexapod visualization is gonna take, but yeah, wish me luck. This is what I came up with. While walking, the legs would be closer to the body. And I'm thinking, so when the feet are touching the ground, this is what it looks like. And when they're not touching the ground, it's almost like they're see-through, like they're in the air. So anyway, let's see if I can put this onto this. The Hexapod is visualized. It's not animated yet, but it's coded in a way that I can pretty easily animate it. Progress is being made, sort of. We're getting closer. We got it working. It is completely working. So if we move the joystick, it doesn't animate the direction the joystick's moving, but the joystick is just controlling the speed of the animation. Just a quick little update to show my workflow using AI. Trying to make a pop-up to select a gate. I want the choices to be displayed in a horizontal list that wraps to the next line if the choice would go off the screen. Here's what it looks like. Okay, so the fix was actually really easy, but if I didn't know how to code, I don't know if I'd be able to fix this. I just had to move that line into the while loop. The gate selector is finished. It's working perfectly. We can scroll through the list, select, and then it says what we selected. The home page, which is what this is, this was the hardest part. So the rest should be relatively smooth sailing, but we'll see. The Gaits page is completely done. We have a little gate visualizer here, and it is actually what the gate is. You'll see that we have two different kind of like selection things. The circle is what we're hovering, right? And that's what's visualized on the right. And then the little greater than sign is what's actually selected. So if I go back right now, Ripple is the gate. Holy crap, guys, I finally have another update. It feels like I've been looking at fonts for like 3 hours. The main thing is the controls page is finished. Basically, press any button and it'll give you a description of like what it does. It is coded in a way where it's very easy to, you know, add different descriptions. It's a new day, and I've already made some progress on the settings menu. So you see we have like this scrollable list, and I have an NRF address item and a dynamic stride length item. So when we select dynamic stride length, you can select either on or off. If we select off, you see it updates. And the cool thing about this is that the value saves. So if I turn it off and turn it back on, it'll stay as off. See, it's still off. I am back after like 6 hours of doing this. This is the original mock-up, and this is what I ended up with. I started with a pop-up, right, this menu, and I've expanded upon that. Now we have a number selector. I've tried to build this in a way that will work for pretty much any number. You can set a min and a max. Developer can set that. And then you can change the values, you can hold it down, change by thousands, by hundreds, and by ones. And when you're done, you select. Now let's look at the string changer. Guys, I spent so much time on this. Shout out to GitHub Copilot. It helped me a lot. We can scroll and hover over any of the characters, and we can press C or D to scroll through them. We can hold to make it scroll faster. And when you're done, scroll over to the check mark. You just want to go back to what it was. You press cancel, and then see it goes back to what it was. And then there's the reset button, which sets everything to the tildes, and the tildes are at the very top of the list. And finally, when we turn off and turn back on, the values are saved. I wanted to make a couple more updates to the settings page, mainly adding some like consistency throughout the UI. I didn't like how, like with the string editing, you had to like scroll to the buttons. I did like how the number editing was though. So I made string editing the exact same way. To enter, you push in the encoder, and then we've got cancel and reset on C and D, and then increment and decrement on A and B. The reason I didn't want to do this initially, it's a dumb reason, but I wanted all the buttons on the, like, below the string, so that if the string was longer, I could like use the entire screen, because obviously you could fit only about 7 characters here before it would overlap the UI with this layout. But I realized that was dumb. You can now scroll if it's greater than 6 characters. Here's what the mock-up looked like for the offsets page. Basically just a really long list, and I wasn't a huge fan of this. Here's what I came up with. We've got a visual of the hexapod, but each servo is represented by a colored circle. And then the one you've selected is circled. So hopefully this will be able to fit onto this. It's been just over 2 hours and I'm done. I made a couple of changes to the mockup. The idea is to just display the offset on each of the circles, each of the servos. And that's exactly what I did. It's displaying -99 because I'm gonna make it range from -99 to 99. I really like this way because you can see all of the offsets at the same time. I'm really a fan in the UI of just making as much info displayed as possible. We've got a stats page. They're all just completely placeholder stats, but we've got a scroll bar, and I've added the scroll bar technology into the settings list and the gates list. I think that's it. Basically, all I've done is hook up the controls, and I've made it so that the NRF address actually is being used. The NRF address in the hexapod is hex01. So when I turn this on, even though the controller's on and we're at the home page, it's not connected. But if I type in the correct address and it connects, I've got all the controls hooked up. We're already back to parity with the previous, so this is a great start. Also, a little change I made to the hexapod. I recut, resoldered, and resoldered the wires to the switch, and then I hot glued it like a lot. So I don't know why I didn't do this before. I would highly recommend hot glue in situations like that. I've successfully linked the gate value on the controller to the hexapods. Also, I've updated the idle state, or the standing state. If you're on any screen except the home screen, it stops receiving inputs. So for example, the menu, nothing works. Right, so if we go to gate, if we go to the gate menu, notice the inputs still don't work. Go to ripple, and now it's ripple gate. Yeah, this is what peak performance looks like, believe it or not. If we go into menu and then offsets, the hexapod goes into calibration mode. These values came, or rather are coming from the hexapod. They're stored on the hexapod and then are transmitted to the controller. But in calibration mode, the controller can alter them. I went through and it is fully calibrated, but I'm gonna mess one up. So the right tibia, I'm going to make really high. So the right tibia is, let's do -30. If we go back, so clearly this is not correct. And if we turn the controller off, and then turn the Hexapod off, and then turn it back on, you can see the offset value is saved. Controller's off, turn the controller back on. I cannot stress like how much nicer it is to be able to change the offsets through the controller instead of having to manually change numbers in the code and then re-upload it over and over and over. I decided to store the offsets on the Hexapod itself because that just makes the most sense. Like it makes literally no sense to store on the controller. The offsets are for this Hexapod specifically. The Hexapod now has a sleep state. If we turn the controller on, it stands up, and this is standing state or idle. And after not inputting any, inputs for a certain amount of time, it goes back into sleep state. And right now that delay is 5 seconds, 5,000 milliseconds. Also, it goes into sleep state when we enter the menu. And then finally, the dynamic stride length. If we turn it off, no matter how slow you make the Hexapod move, the stride length is the same. The problem is, like, it's really buggy, and now I'm trying to break it just to show you. I'm doing this. One more little bonus thing that I added, long overdue. The height dial, it's not jerky anymore. I made it smooth. You can no longer make it jump by, just moving the dial really quickly. This is me moving the dial really quickly. So it probably for the best, to be honest. So when I was making the sleep state and also messing with the offsets, I noticed that I wasn't actually able to make the femurs move past vertical. Now you can see right now, the Hexapod's on, the femurs are past vertical. That's because I completely revamped not only calibration state, but also how you attach the servos. So if we go into offsets, we're in offsets now. To calibrate, all you do is make the femur and the tibia straight up. And then obviously the coxa is still the same. You just want it pointing straight out. And I also changed how you attach the servos for the first time. The difference now is that in calibration mode, the servo limits are not at vertical. That's the servo limit now. There is now a lot more room for the leg to go into its body. So this is now what sleep mode looks like. And I think it looks fantastic. This is exactly how I envisioned it, with the legs curled up. Holy crap, guys, I actually did it. First off, I can't believe I forgot like the most important part of this controller, which is the Hexapod Visualization. This is a bit tricky to record, so bear with me, but this on the controller is not a simulation. It is directly pulling the feet positions from the Hexapod and displaying it. Yeah, I mean, I think it speaks for itself. I am so happy with how this turned out. So like, watch when it sleeps. You can see the feet go in. See? Let's go to wave gate. So sick. So I haven't actually implemented the gyro step or easy modes. It doesn't have anything to do with the controller itself. It's more of like Hexapod stuff. So I'll be saving that for the next Hexapod video. And for the finale, I had PCBWay print the case in aluminum. The process is called SLM, or selective laser melting, and it is not cheap. This cost $450. This is so cool. It's so heavy. I mean, it's aluminum, so of course it is, but holy crap.
So I messed up. This is supposed to go all the way down and fit on this. This is 100. This is actually not my fault. It's Fusion 360's fault, but it's my fault for not checking. It's okay though, it's okay. I can just 3D print this. It is unfortunate, but it's fine. The one thing that I'm worried about is the screw holes. Oh my God, it's perfect.
Also, to be clear, I didn't model the screw holes. PCBWay's engineers tapped them after it was printed.
The rotary encoder is actually shorting out. I mean, it's probably because it's touching the metal somewhere. So let me try to get this fixed. All right, guys, it took me about an hour and a lot of electrical tape. We've got a rotary encoder that can actually change values. Fully functional metal controller case. Guys, don't do this. It's like actually stupid. Don't mount PCBs in a metal case.
But let's be honest, I already knew that, but I really wanted to demo the metal 3D printing that PCBWay offers. And guys, I'm seriously impressed. It's very heavy too. It like surprisingly heavy. It genuinely reminds me of just like stone. I'm not personally sure what I would need metal 3D printed parts for, but I will definitely keep this in mind because it is so cool. Check out PCBWay with the link in the description. That's it. It's finally finished. The next and last video on this will be a tutorial on how to build it, as well as the announcement of the kit. The kit will have everything you need to build this, minus the 3D printed parts. It's looking to cost around $100, not including shipping. If you're planning on buying one, or at the very least interested, please let me know in the comments. It'll give me an idea of how much inventory to buy. While you're waiting for the next video and the kit to release, consider joining the Discord. It's an awesome place to hang out, talk about robotics, and share your projects. I'll see you there.